about quantum, at least it is working as a myth buster for you, right? At least now, if somebody speaks about quantum computers anywhere or quantum cryptography, at least you can relate, or you will know that what is the myth, what whether that person is speaking nonsense or it is something worth listening. You will understand that, right?
Yes.
And one more thing, like quantum computer and the traditional computer. So there is a very nice analogy somebody has given. Like a candle also gives us light in darkness, and electric bulb also provides us light in darkness. But that does not mean that thousand candles together will form a electric bulb. It never happens. These two are completely two different technologies. These two are completely two different things. Yes, both of them provide light, that is sure. But that doesn't mean that if we have enough candles, that will replace the electric bulb, or electric bulb is going to replace all the candles. That doesn't happen. It's a very nice analogy, I would say. Okay, so securing the modern application stack. So how many of you have worked on this application modern application stacks? How many of you have worked with microservices and stuff? How many of you have worked on that?
Somewhat, somewhat for cloud, but not sure what is there on your slide. If you can share your screen.
Yeah. Oh, I'm not sharing. I'm so sorry.
Yeah.
Share. Please let me know if you can see it. You can see it, right?
Yeah.
Okay, the question here is, we know that this modern application stack are usually the way we are creating applications nowadays is quite different than we used to do that 10 years back. Why 10 years? I would say 5, 6 years back also we used to develop application in a completely different way. Now the paradigm has changed, and from the developer's perspective or from a designer's perspective, can you tell me what is the biggest change that happened?
Um, the same as you told, monolithic to microservices,
Yes,
containerization, then Kubernetes came.
exactly. Yes. So the biggest change in the paradigm, the biggest paradigm shift that happened, it is the revolution, I would say, the revolution that took place in last 5, 6 years. And it happened just in front of us. All of us are in the industry while this revolution was happening. It's a revolution the way we develop a product or develop an application.
True.
Yeah, like previously we used to have a different database, an application server, and a user or a browser. Browser connects to this application server where we have web server running, Apache or IIA something, and there is some business logic, business representation layer, and that business presentation layer processes the user inputs or how it is interacting with the browser, and then it has a backend database. It sends the data back to the database, or it just takes the data from the database. So it takes the data from the database. That's how it usually pretty much it used to work. And today it's not like that. Just I'm giving you an example. My keyboard is not working. Please give me. This is a old Amazon website. You know about this Wayback Machine, right? If you want to know that
Yes.
in particular day in history how this website used to look.
How it was look. Yes, yes.
So this is a website and this is so simple. This is the web page we used to have. We can click on something. So everything, whatever we do, it is there is a backend database server. From that database server, it used to pull all the available stuff that is there, all the available items for sale, and you can just go there, click there, and it was like that. And sometimes many, well, like very often we used to have this kind of problem. So this is how it used to work. And this is the outcome of that product. And we in our college days, or even during our days as freshers, we used to use this same website, and all the websites used to be like that. And today's websites are completely different. This is the website that we have right now. And the difference is this is one single page, one single space for everything is written, one single database or multiple database, but there is a business presentation layer that takes all these data from the database and creates one single HTML page for us. Here we have at least on this particular page, we have at least 10,000 different web pages running. Instead of this one, it is actually creating at least 10,000 different web pages or web applications on this single page. All these things keep shopping. Just few days back, I was talking somebody about this fitness band. So it is giving me an example, giving me an advertisement. No wonder in that. I think yesterday only I was talking with somebody about the fitness band. So today, of course, they will show me the advertisement.
Yeah, even if we talk, it will show. If Alexa is there,
It's not only Alexa, anything. Even nowadays, I don't trust Apple also.
yeah, Shiri is also tracking all the data. It will ask for permission.
It's tracking and setting both.
Mm, mm.
So these are the things that happens, and for everything, all this is one single. Actually, this is a different web page or web application running and putting me here. This is a different one. This is buy again something different. So all these things is coming, right? So that's how today's web page is. Today we create something differently, because now it is not only one application server. There are thousands in one single Amazon page. There are 10,000, at least 10,000 applications loaded. So there are 10,000 different such small applications running. So instead of having a big thing in one place, which we call monolith, let us break them into different places in small services. So that's how it used to work 10 years back. We have a ERP, if you remember your ERP website, ERP portal or CRM portal. It's just one portal, and it is quite messy that time. In fact, today we have successfully made it messier. That is different thing. But that time it is one single database, entire load went to the database. The day somebody updates the database or anything happens wrong with the database, everything is gone. So that is that in those days it was that problem. Because there is one single infrastructure for data storage, there is one single data structure for web server or business presentation or business logic server. And there is one way to do the only one single web page to provide the entire UI in one. But now we have changed it. And one of the biggest problem is the downtime, reliability issue, scaling issue. It is very complex because so many things we are doing on a single one space. That is problematic. Today, what we are doing, we are breaking it, and we are running thousands or 10,000 or 20,000 of microservices in one single web application. And every microservices are just having one single purpose. It will just do a small job. For that small job, it will have a separate database. It will have a separate business logic layer. It will have a separate UI. All these things together, so it is a very small software, like very small application. It will. That's why we are calling it microservice. It's a very small service. For that, I have creating everything. So I will not have one single database to cater all these spaces. I will have, if I have 10,000 different things to do, I will have 10,000 different data, small databases. I don't need a very big big SQL server of 100 gigabytes. We don't need that. And why it is possible? Because of the cloud. In older days, for creating a database, you need to purchase a server, you need to have the hardware, then you need to have the software, all these things together, then only you can have one single database. But today it's not like that. Today in cloud, it is within a fraction, within 2 or 3 minutes of time, you can get a database and up and running. So that freedom we have right now. So this is how we used to do. So these are different jobs. These different geometric figures means different job or different services. Previously, we used to have a persistence layer or the data layer, then the business logic layer, then the presentation layer or the UI layer. This is how we used to create. The entire persistence layer, one single team used to work. Entire business layer, one single team used to work. One presentation, one single team used to work. Now we are breaking as per the service. So your service, your presentation layer, your business layer, your persistence layer, and one team will work on that. So till this, it is fine. We have persistence layer, we have the database, we have business layer or all of these logic or the backend server, we have the UI, everything. Now we have created a number of microservices. Now the second problem, what is the problem in this approach? That is very good. This will solve a lot of problems, the scalability issue, downtime issue. It will restructure my team so that I can get better utilization of the human resource as well. Now this has a problem. What is that? Anybody can tell?
Yeah, so if one container is buggy or with some issue, then it will get replicated to all the applications.
That is true. That is true. But that was there in monolithic. In fact, in the monolith, it was more. Like you are talking about if the template is buggy, but we know if we can fix it in the template, everything else will be automatically fixed. But in the monolithic case, it in fact worse because in that case people used to copy and paste, or literally they used to take a copy the file and if there are 1,000 different services, they used to run 1,000 times. So in case they have to go to 1,000 places and make the changes in the 1,000 files. So that was worse. Here, at least the template, if you make a change in the template, everything else you can actually make a change. Not a problem. But in this approach, there is one big overhead coming, the technological overhead. It's not a problem, but it's a technological overhead coming. What is that? How different microservices will talk to each other. That's it. We have a database here, one single database for all the services. It's fine. It was working for me. So we have one single database for everything. From that database, everybody can get all the data. Now, just imagine in the Amazon website, for recommendation, there is one database. For calculating the price, there is another database. For providing the card, there is another database. For storing my credit card information, there is another database. All these different databases are here, right? The problem here is how one service will communicate with another service. Here it is one single database, it's not a problem. From that database, you can fetch it, whatever data you want. But here this is not possible. You need to get the data from different layer, from different services, and it is not in your hand. So there needs to be communication between the services, right? And that is the overhead. Here this overhead was not there, but here we have a overhead. If service 1 needs some data from service 4, it somehow needs to communicate with data 4. And for that, what we have, how we have solved this problem? What is the technology used to communicate between different microservices?
APIs?
Exactly. The REST API, the REST API. how we one microservice talks to another microservice. Previously, we used to call it web services. If you remember, web services were there. SOA, service oriented architectures, these terms were there. In fact, still many people use this service oriented architecture. Actually, when we said say older days, it means only 5 years back. That is really not older. So that's the problem. Just 5 years back, people used to people were very excited about service oriented architecture. This service actually this REST API is nothing but a modified version of this service oriented architecture and the web services. It's the same thing, almost similar thing. It's a REST API we are using right now for the synchronous messaging. That means everybody will provide some window, or it is just a window, we can say window or some interface for other microservices to interact. And the biggest difference between a web server and web services is that web server is for human being. We can access a web page, and web service is for machines or for another process. That was the main difference. Web services always used to give you XML data. Now we are getting it JSON data, whatever. So it is a machine readable data. A machine requests, a machine gets the answer. That's why this REST API is different than any other web server. Okay. So we have REST API. All these microservices will have a overhead that they will run. They have to run some way to communicate with others. Most of them now, almost the de facto standard is REST. Script many people used to use. I don't think nowadays anybody uses script. REST API is almost everywhere. Now, this is called the synchronous messaging, that at any point of time, we can synchronously, we can get synchronized with any of the services. We just want some information. If we know how to ask for that information, we can go to that microservice and we can just access that API. It's simple. And there are something else like asynchronous messaging server, like the MQTT or all. MQTT is very famous if you have used it. It is a messaging queue. It is just it is not synchronous. It is not one by one service just needs some information. It directly doesn't go to that microservice. It has a MQTT broker. It uses the MQTT broker, and MQTT broker gets the information for your service. And how it is getting that information is a different story. MQTT broker can use REST API, or it can use some other protocol like MQTT protocol itself, message queuing protocol. Or there are, and how the message formats work, that is JSON, XML3, whatever the format we want, it should be a machine readable format. And many of us have used Swagger and RAML, all these things, just to check how these REST APIs work. But the message queues are important because if one microservices get lot of different requests from a lot of different other microservices, it needs to implement a queue. Who it will send the answer and when. That's why we need a messaging queue. So all this overhead must be there when we are breaking a monolith into microservices. And how we can integrate them? Yes, we can integrate point-to-point connectivity. Directly our user interface can interact, or directly our client, it is mobile client or web client, whatever it is, it can directly interact with the different microservices, which is most common architecture we see. Also, we can use any API gateway, and API gateway decides that which microservices to go to, and all the microservices always interact with the API gateway, not direct with the client. Or we can have a messaging queue. Asynchronous, when message brokers, we are using message brokers. The overheads must be fair, we understood. And this is, and whenever we are adding some overhead, technological overhead, we have some technological liabilities as well in terms of security, reliability, because you have to maintain all these things. That's why I'm just quickly covering all the stuff that we use nowadays. Another is data management. Yes, we used to have SQL relational database in older days. Older days means 5 years back. Even nowadays, also many places we use SQL database like SQL Server or Oracle. But we also use MongoDB, ArangoDB, all these stuff, right? So these NoSQL database are more popular because they are lightweight. They are mostly they are lightweight and they don't need much relational services, which is very big overhead. It is good for one centralized server. In a centralized server, we cannot use a MongoDB. It's a very bad. It will be a very bad idea. But for a microservice which is holding very small amount of data, I think this MongoDB is much better. It is very scalable, very small, and another big aspect here is it is totally decentralized. So we sometimes need some centralized stuff like load balancer, some service registry, service discovery. All these things we need to implement. Otherwise, it will be totally distributed system. And if it is fine, we can have a good design with the distributed systems. But the problem here is managing the distributed system is very difficult. That's why a runtime governance is required. And this is required not only for the reliability, but also the security. Or this is not only used for the usability issues, but also for the security. Because security, if we want to apply security policies, we have to go to all the microservices. It's better to do that through some centralized system. That's why we need a load balancer or runtime governance where we can implement all the entire firewall only here, not on the microservice. That will slow it down a lot. That's why we need something a load balancer, a gateway, a service registry for access control. That's why we need all these things. And deployment nowadays we are using containers, DevOps. So if you remember 10 years back when we used to work in the industry, we used to have a development team, we used to have a build team, we used to have a testing team, and we used to have a deployment team. Four different teams working. The developers, they used to create some code and then they send it to the build server. The build server people the next day of without failing, those guys will come and would say that hey, your code is not working in my build server. It will happen. It used to happen. And then the developer will again have to run through their codes, and then they have to make a big fight, big fuss. Then somehow they make the build server ready to run the code, and then the build server builds the executables. Then executables are sent to the test server, the testing team. The testing team, the first thing the testing team would say, hey, your building is not good. It is not working in my environment. That would be the first comment that the testing team would make. And then somehow that problem with that interlock will be solved. Then it took again 2-3 days time, and then the testing team tests and then send to the deployment side. The deployment team again will say, hey, this is working in your testing environment. That's fine. It is not working in the deployment environment. And don't tell us to change the deployment environment because this will affect other codes. So again, the code will go back to the developers, and then lot of iteration used to happen, and then finally some point of time it used to get deployed. That was the problem. So probably all of us who are sitting and listening and speaking here, we have seen that pain. We have got through that pain, right? Is that right? Everybody of us has seen that way of industry going, that operational pay of delays. We have seen that, right?
Yep. Not sure about everybody.
Sorry.
Not sure about everybody.
Okay, but you have seen, right?
Hmm.
Okay. Yeah, I think almost all of us have seen these things. Now, thing is, today we are not doing that way. The later in a later phase of these taste build development build taste all these linear cycle was there. So in the later phase we used to use VM. If you can remember, we used to use VM. We put everything, the developer just put everything into a VM and then pass that VM to the building team. So many of the cases the codes were actually embedded inside the VM, and all they need to do is run the VM. And then the Docker came. Docker is a lightweight VM. It is different than VM. I'm not going into the detail that where it is, that how it is different, how things are like how it works. Or I'm not going to detail into how the Docker or container works. But yes, this is similar to VM. The from the user's perspective, if I am running a Docker, means I am running a VM. It's as simple as that. But inside the Docker, it's completely different than VM. It is using the shared kernel. It is using namespace, all these things. So it is. So I'm not going into that. But from the user's perspective, or from the user interface, it is almost similar to VM. And we are whatever the developers are doing, they are putting into Docker. Then they send it to the testing team. Now the business owner said, "Hey, wait. Now you have a Docker. Now what this building team are doing? You are building your own team and you are putting in the Docker. So why do you need a building team? Fire the building team or merge them with the developer. Fine. Now those building and development and building team, they are creating something and then they pass to the testing team. Hey, wait, this is a microservice, just a small thing. Why you can't test it yourself? You are writing the code, you can the best tester for that. And this is not a very big code. It's a small piece of code because this is a microservice. You go and test it yourself, man. Fire the testing or merge them with the development team. So it went to the deployment team. Hey, you guys are building, you guys are writing the code, you are building, you are testing, and this is a small part. You have to just deploy it. Go and deploy it yourself. You don't need a separate deployment team. And if anything goes wrong, okay, the operation, you guys doing all these things, operation will also be handled by you. You guys operate and monitor, and this is a small piece of code. You should not, there should not be a problem. You guys do all these things. So we do not need to have separate development team, building team, testing team, operation team, development team, all these things. Let us merge them together, work them together. The same people will build, the same people will test, the same people will or deploy, the same people will operate and monitor. And most importantly, the same people will write the code. So that comes to a new paradigm or new philosophy of the software development, which is called DevOps. Now comes to security. So when we are using DevOps, we know what is the Microsoft, what is the microservices. We know how the one Microsoft communicates with another microservices. Now we know what is the DevOps or how these microservices are developed. Now the question is how we can authorize these microservices, how we can manage the access control for these microservices. Then comes something called token, JWT token or access token. Some authorization server, which is a different microservices or different service, it will issue some ticket or token or it is just a token, some number, random number, which has a specific meaning for these microservices. And using that token, you can simply go to a microservice, authenticate yourself, and get the information out of that microservice. If you have that access token, like JWT token, so if you have an access token, you can access the authorization server. Authorization server gives the JWT token. Using the JWT token, you can actually access yourself with the microservice. So if this blue microservice wants to communicate with green microservice, it has to have a JWT. It usually goes either it can directly contact or it can use this API gateway. It contacts the API gateway, gets the JWT token from the authorization server and sends it to the inventory, like in this blue, green microservice. Or if it is a mobile client, then also it goes to which microservice I am accessing. It will have different JWT for different client, and it will using that JWT, using that access token, they will authenticate every access request. Okay, not authenticate, authorize every access. There is something called OpenID and auth. OpenID is for who I am claiming, like who I am, and OAuth is for what I am authorized for. It's all of us have used this OpenID. OpenID is a open identification platform. You can use Google's or many of the these login website you have seen login using Google or login using Apple ID, login using Facebook ID. So those things are open ID. We all know. And once so that means you are authenticated. And once you are authenticated, now if you want to access something, for that you need to have the authorization. For that you need the authorization key. Open ID is for user. I can use my Google identity provider to give access to something that I own. And when I give the access to something, say I am just as an example, say I am using right now, I am using some app in my mobile phone. What is that? Some just maybe this one. Say I'm using Slack in my mobile, and I can log into Slack using my Microsoft ID. How I can do that? I have this Slack installed in my mobile. I go to when I authenticate myself using Microsoft. Microsoft provides the authentication authorization token to this particular app. Now every time this app is going to connect to the original Slack server, Slack it always gets authorized using that particular token. But that tokens, how I have created, that token is created by the Microsoft identity provider. And how that happened, because first time when I installed this app, I I have used that micro authorized me using Microsoft, and I went to the Microsoft website. I have provided my user credentials and all. Microsoft provide identity provider given me a certificate. Using that certificate, it gets authorization from the so OpenID is kind of it is accessing the Google identity provider. So it is always kind of what is my identity? It is a certificate. It is not the key. It just provides a certificate. And second time, OAuth is not like it is not a certificate. It is a key, and it is with the actual service provider. Or if I want to go through Google identity provider to the API provider, we can use that path as well. But most of the cases, it is directly accessing to the Slack. So this is with the Google server I am communicating. This is the Slack server I am communicating. Slack server I am passing the key. Google server is just giving a certificate for me. That is the difference between OpenID and OAuth. Please remember this thing. This is very important. And when I say important, it is not only important for the exam purpose. I'm not talking about exams and all, but this is important for understanding the entire thing or creating a mind map for entire thing, what is happening. Okay? And these are the different technologies we used. There is no end of these technologies. Thousands and thousands of technologies are there. So we are having presentation layer or user interface like HTML5, Bootstrap, Ajax, Angular, Node, Android, iOS, all these things. In the application platform, we use Apache Tomcat, which is very common. Then PHP, Java, all these things. Database system, we use usually MongoDB, Oracle, MySQL, all these things. And the platform service, Amazon Web Service is a very famous one, we all know. And integration service, either REST API or JSON or XML, anything we can use. But using all these things, we can create our own microservice architecture. Now comes to security. All this now at least we have quickly brushed up on that what is a microservice and all. Now comes to the security. We have exactly 5 minutes left for Shinu's session. So just slides I'm covering, and then we'll take the break. So good, this is good for security because scalable, everything is scalable. Small piece of code, we can do the unit testing, we can do all the security testing we want. It is very flexible. Anywhere we can change a small code. So we can always think about the security. We can build security into the code. That's very flexible thing. It's very quick development, that is good and bad. But yes, if I have some security problems, security issues, it is very quick. We can fix that issue because it's a very small piece of code. And since it is a very small piece of code, since there are thousands of microservices running, DDoS attack has a lesser chance, because unless you attack the load balancer or gateway, you cannot bring the entire web service down, entire web server down. Like if you want to make a DDoS attack on Amazon website, Amazon landing page, you have to actually make the DDoS attack happen for all the 10,000 microservices. Otherwise, one single microservice is on, that means one single microservice, you can see that service running. You will see that that pictures or the whatever it does. You can see that. So entire website will never can be brought down using DDoS. That's a good thing. Data is always abstracted because it's always using a small piece of code, small microservices. Every data I'm using, I can abstract, and all the other microservices can understand that. I can use JWT for accessing myself at those data. There are distinct trust boundary. Every single microservice is a different trust boundary. It's a distinct one, and there are thousands of good security tools. There are state-of-art technology. Everything is new. So whenever some new technology is coming, that means they are also considering the new security techniques as well. The new threats, new vulnerability, they are resilient to. But at the same time, the security might be very complex. Just consider a scenario where a user needs to log in to access a resource. Now, in a microservice architecture, the user login details have to be saved in such a manner that user is not asked for verification each time, just like OpenID or just like OpenID. Now, this creates a problem. The user details might not be secure where I am saying we are storing it, or it might not be secure if I am using a third-party organization. So that's a very problematic, because just imagine Slack has to trust Google or Microsoft for as a identity provider service. So now Google and Microsoft is okay, trustworthy, but not everybody might not be trustworthy, right? So there is a third party. We do not know how that third party is storing that information. We do not know how they are using those information. And also, if I am storing that is also a problematic. I really do not know. Like, we have to make sure that those information are stored in a correct fashion. And the authorization logic is distributed. When we have a centralized way to do the authorization logic, it's fine. Now, for every microservices, they have a different kind of authorization logic. That's the problem. They are using OAuth, JWT token, and OAuth. Everything is fine. But inside the microservices, the authorization logic is different, because in different parts of different people are writing different code. And the one that Parth said a few minutes back, that if there is a problem with the template, that means the propagation of the vulnerability is very fast here. Security is in individual microservices, so it is very small piece of code. Sometimes we have to, and thousands of different microservices. So we have to think about security in a distributed fashion in the thousands of microservices. Then when we club them together, yeah.
Sorry to interrupt, sir, but I think Shinu ma'am has started the session.
Okay, then let us stop it here, and you guys please go to that session. Okay,
Sir, even you can join in.
Okay, sure. Is there the link?
I've dropped the link in the chat, Teams chat itself.
Yeah, I am also joining. Thank you. Let's go, guys, in that session. Okay.
Cool, sir.
Pranav, can you send the invite then?
It's in the chat.
Oh, okay.